No, we're not talking. We're still waiting on a few more arrivals.
Okay.
Tonight we're going to. All right, afternoon. Tonight we're going to be talking about the least square method, or method to determine the relationship between two or more variables. All right. So what we know that if you're given a finding a straight line between two variables, then the least square method is used to find the best straight line. So those persons who used to do physics are in the lab at UTech. But I tell you that the best straight line is
The best fit line?
So to be honest, I'm not sure. I hear different things from different people.
Tell me any one of the things about here.
There one time so when you have equal amount of values on each side of the line.
All right.
In terms of the point.
Not technically correct, but we work with that. It's not equal amount of, is so that they say you must draw it so that the distance to the line on either side. They say that the distance D on either side is minimized. All right, so the best straight line it minimizes the distance. It minimizes the distance of the points from the line. Now, so I'm going to be taking this from first principle. Normally, you're given a method to find the regression line or the line of best fit. So I want to take a little bit of time out to derive the equation of this line. Sorry, made a mistake. I don't want to pay for it in the explanation. Okay, so it minimizes distance D from the line. Now, so here is the thing about now. Let's just pick one point on the line. So this point is y1, x1, for example. And it's a distance, vertical distance d1 from the line. So And this one is x2, y2. So our line, I'm going to call it some function of x in this case. So the line is y equal fx. So d1 is equal to, if I take the point y1, is going to be, my line is f times fx1, whatever the function is, minus y1. All right. If I plug in f1 in this function here, if I plug in x1 in this function here, then this is going to be whatever the value is, fx1. And d2 is fx2 minus y2. And so forth and so on. And dn would be fxn minus yn. I don't know if you understand, if you understand this, then my life will be very simple. So,
Sir, run it back one more time, sir. Look at cement, sir.
all right.
Please.
Okay. Let me use a different. Let us say that this line is y equal 3x plus 4. And let's say y1 is 5 and y2 is 7. And let's say x1, for example, is equal to 1. What is this, the value that I am blocking in now? x1. How would I find this value here on this line here?
So you would plug in the x value into, so d1 would be equal to 3 times the x value, which is 1 plus 4, minus y1, which is 5.
All right, so
No, 5.
So this line is 3x plus 4. I plug in x equal 1 inside here, that will be 7. So the distance d1 would be equal to 7 minus 5. That makes sense?
Yes, sir.
All right, x2, let's say that is equal to 2. And let's say y2 is equal to 9. So now, what is the distance here now? So I'll plug in 3.
3 times 2, 6, plus 4, 10.
And distance, but this says that it is 9.
Yeah, so that's 10 minus 9, which
So the
would be
distance. So now I'm writing a general relationship. So d1 is equal to the whatever the function is at x1 minus the y value. This distance here that we want to find. And this distance here, d2, is fx2 minus y. So whatever this function is, I would plug in the x value to find the y value, and then we subtract it from our experimental y value. So experimental y value is here. And we find the equation on the line, and the equation on the line, there's a distance between them. And this is what this sum we had endpoints, the line that we want to find is to minimize that sum.
So the ideal perfect line would be sum of D equals 0.
Right. But we want, no. 1 point is on the positive side, 1 point is on the negative side. So in order to not discriminate with positive and negative and make everything positive, we're just going to square everything. And this is what we wish to minimize. We want to minimize all of this here. So continuing with the theoretical trick. So let's talk about the best straight line. The best straight line, first of all. We're going to be generalizing from the best straight line, but it is important for us to understand the best straight line. So let us say that we have a line, we did an experiment, we found some values, and we want to find out which line is the best straight line. And we're not going to try to get to calculate what is the best straight line, y and x. So what we just said, we wish to minimize A and B, which is equal to the sum of the y values minus this y equal ax. So this yi that I'm talking about are the experimental values. These y values are the y1, y2, y3, and so forth, minus ax plus b evaluated at I. Sorry. So, and to get rid of the positive and negative bias, we're going to square everything. So this is the function we wish to minimize in terms of A and B. All right, so we wish to minimize the distance of our experimental. So these are my experimental values. And these are my, this is my best straight line. All right. In maths class, when they say you have to find the minimum, what is it that you are required?
Find the what, sir?
Find the minimum of any function. What is it that they usually tell us to?
I personally never been asked that question about
Yeah,
the
man. Yeah, man.
No,
You must sit in maths class.
Wait, sir,
I
you
mean,
mean
like,
like
simplifying.
you mean like the turning
function
point,
with the
sir?
line? Yeah. Oh.
So you mean
Differentiated.
differentiate and equal to 0
Find the minimum and the maximum.
Okay. So,
when the gradient equals 0.
right. Actually, it's the fastest I've ever been given that answer to the question, including the stint that I did in China. Usually people don't remember say, to find minimum, you have to do. So do that. I usually go around till.
So I'll be undercover right to the end of the class. Yeah, that's why, man.
Oh,
Yes, sir.
I begin to find out. All right. So we need to differentiate this thing here now. This function that we have here with respect to A, and then I'm going to differentiate it with respect to B. So this is a power. So we have carried down the power, that is 2. Sum, put back the function. So this is to the 1. So we differentiate the outside, and now we're going to differentiate the inside. When we differentiate the inside with respect to A, this Y is a constant, B is a constant. So there you go, we differentiated with respect to A. So we differentiated AX with respect to A. What are we going to be left? So let's do it this way. If I have Y equal 3X, and I want dy by dx, what is dy by dx equal to?
3, sir.
3. So in this particular case, X is a constant. So what are we going to? We're going to end up with X. So therefore, 2 sum, let me say this is inside the bracket. So this is X I Y I. This is a X I minus A X I squared minus B X I. This is not a minus. Is equal to 0. Suppose we differentiate.
Sir, wasn't the entire brackets squared, sir, beforehand?
Yeah.
Or-
Here.
Oh, okay.
But it was similar to if we differentiate y equal x plus 2 all squared, and I said dy by dx, let me put 2x plus 2. Then you carry down the 2, put back, subtract 1 times the derivative of the inside. So that is basically what we did. Carry down the 2.
Sir.
Subtract 1, and then differentiate with respect to the inside.
Oh, okay. I see those.
Sir.
Mm-hmm.
Why they never make you teach maths 1, 2, and 3?
Me?
Yeah.
I'm not qualified. I have a first degree in maths, but I didn't pursue it any further. Maths did kind of too abstract. Couldn't bother with it.
All right, boss.
All right. So now, back to this here now. So now we have to differentiate with respect to B. So same thing, we carried on the 2. Y minus AXI plus B. And then when we differentiate the B, we're going to get a 1 this time. So that is going to give me 2 sum. This is yi minus AXI, we can multiply by 1 minus B. And it's supposed to equal to 0. So I'm going to, the 2 multiplied by anything equals 0. The 2 can be 0, so therefore it must be what is inside the bracket. That must be equal to 0. So I'm going to write it like this. So I'm going to call this equation 1. I'll call this equation. So therefore now, I'm going to write like this. XIYI minus AXI minus BXI equals 0. If I carry these 2 over the next side, I can write AXI square minus BXI is equal to XIYI. Similarly, this is still 1. Similarly, I can write, if I take these 2 over on this side of the equation, AX plus B, AXI plus B is equal to yi. So we're almost done. All right, so tell me when we can move on.
They can move on to.
Yeah, you can
Alright.
move on, sir.
No, sir, give me a second, sir.
All right, so I took out something that is very important. So I am going to put it back in when I turn over the sheet. This little summation side. I'll take it out to deal
Okay,
with.
so you can move on, sir.
All right, so let me write down this thing properly with the summation. So it is going to be a, the sum of xi squared plus b, sorry, should be plus. This is plus. These two go over the side of the equation, so it becomes plus. Plus b, the sum of xi is equal to sum of xi yi. And the next one says a, the sum of xi plus b is equal to, well, can just put the sum of b is equal to the sum of yi. So if we write this as a matrix, the sum of xi squared, sum of xi plus, not plus, sum of xi let me rewrite this up here. So not the sum of b, but is b the sum of 1 is equal to,
Well, oh yeah, because I was going to say xi to the 0 power, but that's 1.
right. All right, so solve for A and B. So for example now, suppose I performed an experiment, x, y, and when x is 0, y is 2, when x is 2, y is 5, when x is 3, y is 7, and when x is 4, y is 8. So we need to find x squared, xy. We have 4 values. So let's see how we set up ourselves here. Let me just write it down here before I go back. So this is x, this is y, 0, 2, 3, 4.
2, 5, 7, 8.
2, 5, 7, 8. We need x squared. We need xy. We need the sum of x squared. We need the sum of xy. We need the sum of y. We need the sum of x. The sum of 1 is 4 times, we're going to add 1. So this part here we know is going to be equal to 4 in our matrix. So we need the sum of x, 9, 7 and 7, 14, and 8 is 22. Sum of x squared is 0, 4, 9, and 16. Xy is 0, 10, 21, 32, 13 and 16 is 29. 32 and 31 is 63. So this is 29.
Sorry, one.
What again? What again?
It's 53, not 63, because it's 32 and
Plus
21.
10. Plus 10, brother.
Never see 10.
Okay. All right, and it's 4 values that we have. So this is 4. A, B is equal to sum of xy, which is 63, sum of y, which is 22. So AB is going to be equal to inverse of 29, 9, 9, 4, 63, and 22. All right. So we just use MATLAB and solve it.
So can I go back on the next page for a quick second? Okay, sir.
All right. So we're going to use MATLAB. So we find x squared, xy out of everything. So we make this equation and then we're going to use MATLAB and solve. All right. So our square matrix, which I'm calling A. Oh, you see in this MATLAB screen?
Yes, sir.
Okay. So that was what, 29, 9, 9, 4. B was 63.
Sir, isn't it 24 and not 29?
$29.
29, man. Xi squared. Sum of xi squared 29.
29.
Oh, my bad.
Create a new statement C for the inverse of A, sir.
So yeah, x equal the
I-
inverse of
Over
a times b.
So, okay.
So my equation for base straight line is y equal 1.5429x plus 2.0286. Let's put that in my. You can do the same thing with Excel and get your answer. You know, here.
Sir, at 9 you have, is that X?
Run again. (1.5429x) plus 86. All right, so let's do it in Excel. And put our experimental value. So x, y, and what was it? 0, 2, 3, 4. And what were the y values again?
2, 5, 7, 8, sir.
So we'll draw the graph. We would have our 4 points. We would go over this side. Sorry, we click on one of the points.
You need to turn on add trend line, sir.
Add trend line. And then it will be linear. And then we'd say display equation. And the same answer. All right. So so that's fine. So like I said, we're dealing with thing from first principles. So what about now? All right. So what about now? Suppose we wanted to fit a quadratic equation. So
The best fit line for a quadratic or the best fit curve?
well, the maths teacher will tell us a curve is a line.
All right, sir.
All right. So again, this time our function is A, B, and C. I want to minimize over all I the y value minus ax squared I plus bx plus c. We want to minimize the sum of the distances of the y values from the line. So again, we will differentiate. So we'll find with respect to A, so that is 2 or differentiate with respect to A, would get x squared. Differentiate with respect to B, and differentiate to B, would get x. And then differentiate with respect to C, so once again, what we are going to end up with, to multiply through and carry, all of them supposed to be equal to 0. So we're going to end up with ax I to the 4th plus bx I cubed plus, so that's a sum, plus cxi squared is equal to the sum of x squared y. And would end up with, again, ax cubed plus bx squared plus cx is equal to sum of x, y. And then finally we'll end up with ax squared plus bx plus c is equal to y. Or if we write it as a matrix, this is going to be sum x to the 4th, sum x cubed, sum so we'll solve that for A, B, and C. So let's use the same values that we had before. So the same values that we had before. We need to add x cubed, x to the fourth, what else doing? X squared y. So x cubed, that's 0, 8, 27, 64. X to the 4, that's 0, 16,
81,
1,
81,
256,
256.
256.
x squared y, that's 0, 20, 63, 68, 48,
128.
8. So now add
99,
99,
97,
now
353.
3.
3.
and then you set up on this crucial HT.
Just click on the add-in stuff.
211 is the last one.
So the matrix is x to the 4th, which is 353, x cubed, 99, x squared, 29, and this is 99, 29, x is time, this is 29, 9, 4, ABC is equal to 211, 63.
Drop that in MATLAB to solve.
So that is first number was what, 353,
Yes, sir.
then 99,
Yeah.
99, then 99, 29, 9, 29, 9, 4. That were those numbers there now for the next the column vector. You remember them.
211.
211, Then the online, just spend the time and look for it. 211. Okay. And then
Three.
the next number is what?
63.
63.
22.
2. So x equal in so my equation is y is equal to minus 0.0455 x squared plus 1.7182 x plus 1.9636. So that will be the quadratic equation through the curve. So again, let's check it on Excel.
So it's just to change the trend line now to a quadratic because it's the same values.
Right. So change it to polynomial order 2. Ask to display the equation. So that would be the quadratic that would best fit the line.
So you do that more of a curve, sir, or something like that?
Supposed to be a curve. Supposed to be a curve. All right. But the curve that is supposed to be, you can see by the coefficient of the x squared that it is a very gentle sloping curve. X squared is minus 0.04. So it's going to be a very gentle curve. All right. So let me go where Excel cannot carry you now. Suppose where are we? Okay. What about if suppose
So
that
you're
is
seeing the screen for the quadratic equation?
if I you're
The
not seeing
screen,
the screen?
no, the screen previous to this one, sir. Where are this quadratic equation? You erase it?
No.
Can we see it back 5 seconds, sir, please? Yes, sir, the screen, please, sir, 5 seconds. Respect, sir, can you me?
All right. So we're saying now, suppose it was y equal a sine x plus b. Well, same thing. Sum of y minus a sine x plus b. and we're taking the square of that. So the partial derivative with respect to A is going to give me 2 sum y minus A sine x plus b. I will differentiate that to get sine x, differentiate A, and the derivative with respect to b times 1. So we're to multiply everybody by sine x. We're going to get A sine squared x plus b sine x is equal to y sine x, and A sine x plus b is equal to y. So it's going to be sine squared x, sine x, sine x. All of these are sum. A equal to sum of y sine x, sum of y. So our x or y, we need sine x, we need sine squared x, we need y sine x, this is 0, 2, 3, we're gonna 2, 0, 2, 3, 4. And what was y again?
Sir, 2, 5, 7, 8.
5, 7, 8. So sine of 0 is 0. We have to put the calculator in radian mode. So sine of 2
0.9.
sine of 3
0.141.
sine of 4
Minus 0.756.
square that,
757.
7. Yeah.
square that. Can square the other one if I'm trying.
So 0.020. Next one is 0.826.
0. 4.545. No, from from the other side, sir. Another 0.
4.545
545.
times 7. All right, so if I add them up again, so this is so
Are
much.
you sure about that one?
No,
Isn't that
no,
one
sir. Hold on,
0.987?
sir. 0.8.
0.987
0.917.
Which one?
for
0.14, yeah.
you use sine squared x or not sine x. A while ago.
0.987.
987.
All right, so I have to add up everything again. So 729. So 22. I add up the last row. So I add up the second row and third row.
Sir, question,
Hmm?
sir.
0.293.
Yeah,
The,
the question.
the last one, sir, isn't the last two numbers supposed to be negative, sir, for the y sine x?
Yeah, so they're supposed to be negative.
So that one is 1.599.
Add up this again. 4.545 plus 0.987.
The last one is 0.948.
Well, then, all right, enough, sir. Hold on.
Sir, check the
Last
one now. A 1.419 or 1.519.
Which one?
The one under 0.573.
Oh. So is that 0.826 or 0.876?
826.
Oh. I use 876, my bad.
Oh. 1 point how much? 1 point how much? 419. All right. So this is 1.419. 0.293. 0.293 for AB is equal to y sine x.
Sir, the last one under y sine x is a negative 4.584.
Yeah, this one you're supposed to be on it.
Okay.
All right. So once again, go to MATLAB.
Sir, well understood. I've got it in all right, sir.
Which
The
one?
last one, y sine x,
Uh-huh.
that should be 6.056. Isn't it y times sine x? No, y times sine square x. It's,
Y times sine x, yeah.
yes, sir. That should be negative 6.056.
Well, everything add up to.
Sorry, just make a change of
Yeah.
Again, negative 0.553.
Negative 0.553.
Three.
So we'll go.
Yeah, sure, what the last one is.
Where's my phone? Yeah, we need to take a. Oh. All right, so once again, just put it in a MATLAB.
Yeah, the last column is sure what the value is.
No.
You're right, you're right, sir. You're wrong, sir. 0.524.
Yeah, that me get to.
Sir, why you say that for dinner radiance?
Why what?
Why is that for dinner radiance?
No, well, all our engineering calculation, it when it comes to things like this, we never use degrees because degrees, engineering calculation never use degrees under normal circumstances, unless it's, especially when it's electrical. I've never seen a situation where we use degrees.
As most times we get measurements like 2 pi, 4 pi, 3 pi.
Right. Right. All right. So, okay, just finish this problem here. So we're going to go to MATLAB.
So was that 4 or 41?
That was 4, man. Sum of 1.
Just
Four
Yeah,
elements.
sum of one. Sum of one.
4 elements in the Y, so that would be 4.
Ignore that. As usual, I have to wait until the MATLAB load up. All right, so A is equal to 1.419. And then next one is 0.293. Zero point two nine three.
Sir, that look like also, sir.
Yes, sir. You
Oh.
get a little error in your calculation term is.
If you see me looking like our old man at the calculator here, you would have. And then B equal negative 0.524. 22. So inverse A. P. So that would be my Y. So that would be my line of best fit. So I mean, there are a whole lot of different scenarios where you get some data you need to fit a curve, whether it be sine or exponential or whatever the situation is. And then you would need to come up with a set series of equations to solve it. But the least squares method is able to find the best fit depending on the equation that you have. All right. Homework. This is the equation that I wanted to fit the curve to. Same set of data. So tell me what, when you differentiate with respect to B, what is it that you're going to end up?
So with respect to B or A?
B, I want B. A easy.
Two
Summation time.
summation time.
What?
E to the BX. E to the BX.
This was also no wonder why there were so many people fleeing in a sorry state under the airship. Sir Molly.
Can you show the A to the left?
The X, sir.
Can you show another the E to the BX alone for the left?
Yeah, E to the BX. Clear.
Although Molina did not use his power to bully others, the three people around him seemed to
I was stressing with that at this point.
not love, and all of this was because he was due. Percent eldest son,
Good thing,
younger
you know.
brother. After all, Hoover had already been appointed by the Duke as the next Duke. So that's the case. Then Sir Molina must let us meet Sir Hoover. I've been looking up to Sir Hoover for a long time.
Yo, Shane, mute your mic, brother.
Oh, sorry. My audio book up today, sorry.
All right.
Sir,
So,
what are you doing? You change the homework?
yeah,
All right.
I didn't want to create the, you'd have to go use the symbolic part of MATLAB because of that. That's the equation. Yeah. Work with this.
Sir, when this one due?
Next week.
So I have a good amount of homework, just because we can't get MATLAB. I mean, I try to get it online, and I'll be a random link it to send me to.
I forgot send me your email address out to see if we can start out MATLAB.
Sir, all right, so the homework is y equal a cos x plus b or plus bx?
Plus B, plus B.
Okay.
All right, so same data. So we stop in there.
Sir, question. Where do you upload the videos? Left or not?
I see all of them on YouTube. It's not me upload them, by the way. It's Mr. Who's who always upload them? Mr. Vassal always upload them, no so.
Yes.
So search for Vassal
Yes,
in the
sir. What's up,
YouTube.
sir?
Huh?
Search for Vassal in the
Yes, sir.
Yeah, man, if you type the video.
Yeah, and then the group too.
Mm-hmm. Let me type in English.
Yeah, can you add me in the group, please? I just send the link in a message or something.
Yeah.
I just join there.
Yeah, so we have the
Hey, sir.
It's on YouTube viral. Last week one was 5 views. So
Sir, when you say you're not coming to class again?
I never say I'm not coming to class again.
Sir, this question that
Sure.
you have given, sir, you just want it to be you want it to be handed in or just presented in class, done for class?
No, I need everything. So that I can just add them up and we can have a discussion at the end of term.
Where you want it, how you want it to be submitted, sir?
Preferably email.
There is about add up, sir.
Saying that we can just add them up at the end of the. So instead of doing 2 tests, you can just choose to do 1. So use whatever you get for this as the next one. Yeah,
Sir. Sir.
But we will have that discussion at the end of the term. Yes.
Yeah, you don't work with syllabus or anything then?
Here's the problem. Yes, I work with syllabus. I'm not set out the syllabus yet. And here's your problem. Not really mine. Here's your problem. They come on and tell me, say, you have to teach this course named engineering analysis. I say, okay, so what is it that I work with? Oh, you have family syllabus, so
just freestyle.
so in other words, yeah, I would send you the list of topics.
All right, so I just vibe.
Huh?
Any books, any textbooks?
And I keep on saying I was sending the textbook. It's you're not holding on my phone. So I probably have to send it.
Sir, just tell me what
Why
book
in
is
there,
on the
man?
Senate in the group. What book is it?
Engineering mathematics.
By who?
Let me, the name in my head is the wrong name. So let me just look.
Engineering
The name,
mathematics.
Textbook. We're still not sending it, sir.
it, Advanced Engineering Mathematics by, let me get his name. Crazy, right.
By
You
who?
have it already, we have to go down with it.
I have it. It's just for me to send it.
Yes, it's
Crazy.
enough.
All right, let me try to send it now.
We're sending it in the WhatsApp group.
Yeah, I'll try again.
All right, sir.
All right, so that's it for today.
All right, sir.
All right, sir.
We're gonna send it, try to send it to the group here now.
All right, nice, sir.
Good night, good night.
Ah, nice, man.
Yes, good night. Night.